the
That would make
it's not going at a velocity, it's spinning at a velocity.
Or we could all just shut up and listen to what he has to say.
I want to die.
There's probably something awesome at science that we don't understand and can't hope to figure out. He's going to mention Einstein at some point.
Again.
Please let there be quiz corrections.
There are, but they're like the redemption quizzes.
Hello.
Oh! I heard you guys.
You did better than the rest of us.
Well, you know, Schrodinger's capping. I both failed and did not fail.
I got one.
Give me like.
I just went and looked, and this test actually went better than last year, which is probably due to grading irregularities. There were different problems as well, right? So that's but anyway, it went not as well as last time.
Wait.
The meeting was somewhat lower, like 40. No, I'm just kidding.
Don't be cruel to us.
Don't hurt me. I'm already scared.
Don't be cruel to us.
I
Any more than you have to
My
be.
future.
Dr. Dom is cruel for a
I don't
living.
think Mike can drop my.
That's a good quote, by the way.
That's a good quote. He wants us to put it on
minimum
the
of
page.
55.
He's self-aware.
Working on.
So we're guaranteed
My
to be.
death.
The mean is right around 80. Not so bad.
Wait, that is worse.
So, I mean, lower than last time, but
What is
not so
the,
bad.
what's he called? Standard deviation.
So,
We should be like,
What we
you know, the biggest problem with the grade, you know, I basically don't like the way we have the grades so electronically available to everyone and their mother, literally, is that like, you get grades too soon before they make any sense, which is going to be the case in this class until like the quarter break. Because we have 3 categories: exams, quizzes, and projects, and you're only going to have quizzes in there until like October, and the quizzes are the lowest scores. So actually, exams might be, but anyway, the project
Don't do this.
the lowest scores at least until the redemption quiz. Which, by the way, doesn't help you as much as you might want, but it still usually helps. But because there's no project stuff, I used to start with some project stuff. I moved it because I really wanted relativity first so that you could understand it better, based on my experience last year. But because of that, we don't have any project stuff for quite a while. So when your parents come here on Parent Day, they'll be like, "How come my son is failing your class?" And I'll be like, "Your son is fine. It's okay, but you should probably study more anyway." You know what I mean? But like, it's having to explain that to administration and to the parents and all that is annoying, and I don't have a particular. I thought of several solutions, none of which I liked. Like I'm like, oh, I could put in a dummy grade for projects to help offset it, but which dummy grade would I put in exactly? If it were 100, then it'll artificially inflate your grades. You'll complain what happened when I do put in the first project score, it'll make your grade like plummet, right? And then like if I put it 85, then it'll pull some people's grades down, and all sorts of like. So anyway, I think the best solution is just we all learn to deal with it. Okay, the quiz grades are low. I know they are. The grade distribution this class at the end of the year semester is typically fine by my standards. Meaning some people get A's and some people get B's and some people get C's. And I haven't had any B's for a long time.
has anybody failed?
Oh, I've gotten them before, but I haven't had them for a long time. And then mainly those first 2 years when I first started teaching classes and it was still taught as a blow-off class. Do you know that?
Wait, what?
It was the blow-off class, everyone. Yeah.
What?
That changed quite a bit.
They had someone else teaching it. It was kind of a lost class for him. That teacher left, and Mr. Lawrence, who was, well, you wouldn't know Mr. Lawrence, but I think he was there, and he taught it just to fill in for a year or 2. And then they hired me and just asked me to teach it, and I'm like, sure. And no one told me, oh, by the way, they did a blow-off class. And so I didn't, and then things changed. Yeah, so anyway. Now it's fine. So the point is, the grades will be fine. They will be reflective of, of your performance in the class. But right now they will be low. Like I can't find any good way around that. I care more about running the class properly than about getting the grades right in September. Right? Who cares about getting the grades right in September? But I do say, I wish there were ways I could just line power school, but I can't because administration required me to put in a grade before Parent Day. So, anyway, So, as always, if you're not happy with your grade, decide what you're going to do differently next time. And you can be honest and realistic about the amount of time you have and about, right, because you have other classes, I understand that. They're not as important as this one, but they are, you understand, spend a full time on that. But I mean, be realistic about what you can do, but think about what steps am I actually going to do. A lot of them might involve A, studying it all, or B, studying earlier, right? And then C, studying right. If you study mainly by reading notes, you are probably wasting your time. The way to study is to do problems, not to read notes. This is true for virtually every physics class. I learned this by the end of college because I'm kind of a slow learner, but it's still true. You study by doing problems, not by reading notes. When you do the problems, that's when you learn all physics. Okay, so that's my recommendation. All right, let's do this. Say,
It's terrifying.
Alvin, Micah, Nicholas. Sorry. I didn't do that on purpose. Eric, social.
Maybe still passing? What's the end passing grade?
Passing is a C or above.
So 7.
Oh, I'm after that grade, I was questioning whether I was
Okay, that's improvement by like 2%.
You did better than me.
But that's improvement.
I went down by 9%.
I went down by 10.
What's the other time went down by? I bet you it's at least 5%.
My entire
You probably got the same grade.
my entire quiz is meh.
Isn't it?
That's my average grade. Meh.
I got check minus, wrong, meh.
What's check minus?
Nothing, and meh. It goes check minus, meh, nothing.
I got a check minus on the ninja?
Wait, what is it?
I mean, you just mess with it.
I got meh on the ninja and wrong on the other ninja.
Well, this was Tashna's. You put the wrong person, that's the reason why you Well, you know, you might got the different
It's still a
thing.
point. I'll take it.
Where are quizzes?
At the bottom.
Apparently, this is just nerve-wracking. Just get it over with.
He's doing this on purpose.
I know.
What if he wants to see us after class and that's why he's withholding
He's
our
holding our
That can't
papers
be
back
it.
just so he can come and smack us down.
You put like 100 in the last one. You should
No, I didn't. I got a 91 barely.
stop it.
What's that?
Stop
Can
it.
you please contribute to the notes that I have on Google Drive? Please? Can somebody?
About that, I have like
Those actually help me a lot in the course. Thanks.
Notes.
What?
Hopefully you really understand it.
in addition, I have the working pictures.
On the Google Drive?
No.
Why not?
Put it on the Google Drive. Why not?
I just haven't gotten around to it yet. I probably should have done it, but
I told you this was going to happen.
how did you do?
Man. Check minus, wrong.
I went up by like 7%. I went up by like 7%.
What did you get for 4?
Better than I thought I did. What did you get?
You got what?
87.
Okay, wait.
I feel like I'm wrong because I got inverse on everything, and this one I just... I was close on this one. Wait, oh yeah, because I was...
I got 2 check minus, 2 meh, and 2 wrong.
I'm still not quite happy about the grading. Something's not, the level 3 is too heavy a weight, and I'm trying to figure out how to fix that. But I will work on that. In the meantime, statistics will wash it all out. Let's say there's an element of luck in level 3 that weighs too heavily. But then I'll work on how to fix that. But on the other hand, it's luck that you can kind of still get a good average. Right?
Okay, so I'm passing. Barely.
All right. Well, let's talk about the actual physics. It's the important part. Okay. So number 1, bombs. And all the times are given in the Train's reference frame, right? So the Train's reference frame, if this bomb goes off first, then this bomb goes off by 3%. which takes how long? 1 second.
Well, this is
So
actually
one light second,
74
right?
now. This one's like
So this is
72.
1 second. The distance is 1 light second.
It's more like 73.
Okay,
Something.
those should be the coordinates of your two events. You cannot do this problem with time dilation. Why can you not do it with time dilation? So, no, what's the reason, Jay? There's no proper time. In this reference frame, these do not happen at the same location. Therefore, and in the Earth's reference frame, they also do not happen at the same location. Therefore, neither frame has the proper time, and you may not use the time dilation. That was pretty generous with the partial credit on level 1. Pretty darn generous. But anyway, maybe that's why the grades are higher this year. Anyway, whatever, it's fine, I don't care. Okay, now we're going to the Earth's reference frame. Now, if we're going to the Earth's reference frame, v of therefore is the velocity of.
And I didn't even simplify it.
If we want to know the answers to the Earth's reference frame, v should be the velocity of the Earth, right? So it's always the one you want to know. If we know the frame we want to know in the Earth, then v must be the velocity of the Earth. And that was, I think, the biggest single mistake people made. Was the most common mistake I saw was making the wrong velocity. So what's the velocity of the Earth relative to the train? Negative.
It makes it a lot easier.
Yeah. Like how
At
this
this
freaking
point now,
out to
we just need to find, do a transformation of base to the gap. This is 5/4.
It's just so
great.
I'm going to make a quick comment here.
can't make this 5/4.
When I teach MSI, there are some people who clearly do not have good
Yeah, it's
preparation in
middle
grammar and
of the
writing
forehead.
for a variety of reasons. Okay? There's not a lot I can do
Yeah, it's
about
gone.
that except
It's
I
gone.
say, you
Yeah.
work with the writing
a
center,
little, like,
writing,
whitish
it's
yellow
not my
dot.
job to teach
That's
basic
weird.
grammar, and I can't spend my time doing it, but it does affect grades. All right, in this class, it is clear that there are some people who do not have adequate preparation with arithmetic manipulation of fractions. That is, say, it takes you a really long time and you don't know how to do it very well. This is not everyone, but it's a good number of people. Okay? If this is you, once again, this is considered in the state standards as second foundational knowledge, right? If you are struggling and spending a lot of time on the fraction, all I can say is you need to go practice fractions, right? Which you can do by just calculating gammas and things like that. I mean, it's easy to use how you really need to do practice problems, right? But you need to be able to do this stuff on your own, and if you don't, you're going to keep on struggling throughout. And that reflects your upbringing, and I am sorry about not like your parents, more like your education, and I am sorry about that because I know it's not in your control. But anyway, this is where we are, right? So if you're having trouble with the fractions, you need to go work on your fractions. And you keep on trying to use decimals, you should start noticing that it stops working after once the decimals start getting big rapidly, and it doesn't work very well. It's the same. All right. But reduce your fractions first, guys. Lots of people working with large unreduced fractions, and it's much better to reduce them first. It saves you a lot of calculation. Okay, that being said, let's finish this. So the time coordinate, this of course will still be the origin. For this one, the time coordinate will go to the time minus b, so negative 3/5, 6c is the same as over c squared, and then times 1 light second. All the factors of c cancel. And what we get is 5/4 times 1 plus 3/5. And that plus because the velocity is a negative sign on it. And that was, like I said, the most common.
Freaking out, like, this isn't making any sense. Why do I
Which
have
gives you, remember that 1 is the same as 5/5, so this is 8/5. The 5's cancel, 8/4 is 2 seconds. Sorry.
Squared, that shouldn't be squared, and that should be a negative.
Some of you may have noticed that as long as the units are accessible things like light seconds, that you can kind of go a little faster loose with the units, and you're quite right, that's fine. Okay, and for number 2, all you need to do is find the x
minus
coordinate.
minus.
This is the same as the distance between the two events if you chose one of them to be the origin. The origin is always the origin, so that will be 0, and then this will be something else. Okay? So the x prime ditto, the distance between the two events is just the x coordinate if one of them is the origin, because that will always stay 0. So this one would be 5/4 times 1 light second minus negative 3/5 c times 1 second, and you may notice the math of this is identical, so you get the answer 2 light seconds. Okay. All right. Then Wotan is pronounced Wotan, by the way, not 1 ton. Well, that was the other class. One of the other class wrote 1 ton for his name. That was insulting to a god. You know who Votan is?
I'm sure I can help.
Yes, the one that one state is named after. More common in English called Odin. That's right. Votan is the more proper name for Odin. Something bad happened in translation, I guess. The Norse god of everything. Right, father of Thor. Anyway, Valhalla is where the dead Norse warriors go. Right, east. So why run out and chop off things? Yeah, I believe so.
Who's who? Actually, no, there is. Look, proper distance.
And then Alberich is the
between them, one light second.
Creates the ring of the Nibelungen. All right,
It doesn't
fine.
help that
Moving
much,
on.
but it's still
So, Votan is on the Rainbow Bridge, which, by the way, is how you get to Valhalla. Here's Votan. And
his legs look pretty screwed
he is traveling. This is Valhalla, and he is traveling.
I knew this, but like, I'm surprised he knows all these things too.
Sorry, I need the spiritual limit. He throws the ring. Now, Alberich is in Valhalla's reference frame. And in Valhalla's reference frame, he sees the ring going at point 1c. And we want to know what is it in Votan's reference frame. What a lot of people did is set up the velocity equation with u sub x as the unknown and u prime sub x as the known. That works, but as you may have discovered, is hard. The easier way to realize is that the velocity transformations are always symmetrical, right? You can use them in either direction. In other words, this doesn't have to be your u prime sub x. You can make this your u sub x, which will make your math a lot simpler. So I think the simplest way is we know it in Valhalla's reference frame, right? In this reference frame, we have the velocity of the ring is 1c, and we want to know it in Votan's reference frame. Votan is moving to the east, right? Votan is moving to the east at 0.3 seconds c, so we have a velocity of 0.3c, right? The v of, v of 0.3c. And then, if you want to know his reference frame, then you just use our regular equation. Let's go ahead and convert these to fractions for ease. Alright, let's cancel. Alright, on the top we have negative 2/10 c, right? 1 minus 3 is negative 2/10. At the bottom we have 1 minus 3 over 100, right? So here we have negative 1/5, that reduces. At the bottom we have 97 over 100. We have 1 is 100 over 100, right? And that means we have negative 1/5 c times 100 over 97. This cancels down nicely, and we get negative 20 over 97c. The negative sign means it's moving in which direction?
Oh no, I forgot the negative.
Okay. Does that make sense? Yes, it does make sense. He's going this way, the ring is going slower than him from this reference frame, right? That the only way for that to work is for him to have thrown it kind of slowly the other way, right? Otherwise, if you go forward in his reference
slowly when you're
frame,
throwing it like 100 speed of light.
Yeah.
You should talk to him about that. Because that's clearly a simple.
Yeah.
It shouldn't stay.
All right.
I think I can make it.
It might be
Okay. Yeah. Sure.
What happened?
I got the
He
entire
got everything right except for the final multiplication, in which he screwed it up. I cross multiplied.
You crossed me.
You didn't even cross multiply. I did 1,000 over 2 times 97 is 97 over 500.
Why did you cross multiply?
I don't know.
Okay, you are an idiot.
Shouldn't that have been a check minus? Yes, I think there should have been a check minus. These I can see where you were wrong. You really didn't see the work, but this one, you did everything right except for this.
Just talk to him about it, and you'll probably get a better grade.
Okay. You might not even be filled. Yeah.
Failing grade, like just the term. I don't even want
I
to.
literally, I have the right answer.
Nothing in ModPhysb is failing. Taking this class is
Yeah, easy.
Where
did you go wrong?
I realize that upon reflection. There are two ways to do number 4. One way turns out to be a lot easier. Not easier, but easier to not get caught. here they are. So we start with Faith and Tasha. They jump apart at the same speed, 0.2c relative to the Earth. So this is the Earth's reference frame.
I have this problem.
Okay. Now, there's two ways to do this, and I'll show you the way that I intended first, and then the way that some people did, whereas both of them give you the same answer, but one of them, which the way I originally intended, is a tricky way, because there's a trick in it. Okay, the tricky way, so the way I intended is, just get the coordinates of when they throw the ninja star, and that will give you when the ninja stars, and that transform the coordinates, right? And that should give you all the information. Okay, there's one problem with that. You may be tempted to write something like this, and then 0.2c, so 0.4 seconds, right? You might be tempted to write that. Oh, sorry, negative. You might be tempted to write that for Faith, I think. Actually, it doesn't matter who's on the left. I think in my head, Faith was on the left.
But I did.
Okay. Faith and Tasha, by the way, you probably know that reference, but they were two students of mine from a while ago. Or now probably ninjas. Probably.
Ninjas. They're probably
yeah, I have a story about Tasha I'll tell you later. But it'll make more sense. You might want to write this. However, you would be wrong. Why?
You have to say change the origin.
Because the 2 seconds is whose 2 seconds? No. Their 2 seconds. They each waited 2 seconds. Right? If they waited 2 seconds, that must mean in their reference frame. So it's not 2 seconds in the Earth. To figure out the time coordinate, you would have to figure out how long it would take in the Earth's reference frame, which requires a time dilation. Simple time dilation because they're just waiting, so in their reference frame it's proper time, right? Anything that can be counted on a clock, the clock is the proper time. So if they had a stopwatch they were looking at for 2 seconds, that's proper time. So the proper time is 2 seconds.
Yeah, oh wait, I did too.
The gamma for 0.2c is 1/5, so you guys, it's 1/5, right? So
Yeah, what happened is I was probably barely off on this, and then my work was so disorganized.
Right? Okay. If that took you longer, it's fine. But if it took you too long, you should practice it. Okay, the gap is, so therefore the time in the Earth's reference frame by simple time dilation would be these two multiplied together, let's say 5/√c.
Minus 0.16.
6. 6.
Wait,
whatever.
10/84.
And then the x in the Earth's reference frame would be how long, because this is how far she traveled, she's going 0.2c in the Earth's reference frame, so this is the distance she covers then, right? So therefore, it'd be this times 0.2, which is 1/5, so it'd be 1/√6.
Why not?
Or negative. Okay. So actually, the two coordinates would be 5/√6, negative 1/√6, 0, 0. You notice I've been leaving off units to get it floppy with them. Cool. The other one would be 5/√6.
Oh, so it should have been negative 1/√6.
They've done to each other.
Now, you could do what some people did,
right.
transform both of these and then take the difference between them and find the time between
That
them.
makes sense.
But there's actually a simpler way to do it. Anyone see it?
If you set one of them as the origin.
Good. Change one of them to the origin, right? Then you have to do one transformation. Much easier. So,
That's what I tried to do.
I tried both ways, you get the same answer. But if you set this to the origin, then the time coordinate of this one would be 0, because they're simultaneous in the Earth's reference frame. Right? The Earth's reference frame is the same.
Yeah.
So that's 0 now. The space coordinate, though, is certainly different. It'd be what? 2/√6. Good. Right? Because that's how far it is from here to here. Right? The difference between these. And then 0, 0. Okay? Now, if you want to transform, you get, the velocity that we're going to transform, if this is Faith, and we want to know Faith's reference frame, then the velocity of Faith is negative 0.2c. If you did it the other way, it would still work out. Yeah, it still works out. So the time in Faith's reference frame, I already have this velocity, I already have the gap that goes with that. So it's going to be 5/2√6 times time coordinate is 0 minus negative 1/5 c, or c squared, times 2/√6 c seconds. The C's all cancel like they should. You end up with the negatives cancel as well. You get 5 over 2 root 6 times 2 over 5 root 6. How about that, huh? And so what do you get? 1/6 is your answer. No square roots, interestingly, in the answer. Second. And since Tasha's coordinate would be 0, I transformed, Faith's coordinate would be 0. I transformed Tasha's coordinate, and so the difference between them would be 1/6. Right? If you did it some other ways, you might end up having to subtract off some things, which was not a big deal. And then, yeah, and so that would be your answer. That's the difference between the two coordinates. You could have done it by transforming these, and it would work, but it's more work and more room for mistakes. I tried to give you good partial credit if you did the right thing and just made mathematical error. But that would require me to know what you were doing, which in some cases was clear and in some cases was not. So if you prefer partial credit, please try to make sure it's clear what you are doing. This does give a reference to people who are neat, organized, and have good handwriting. Yes, it does. Okay, the other way to do this, which is actually, it's actually about the same amount of work, but it doesn't have that trap that's easy to miss right here, is to find Tasha's velocity in phase. I don't think my math is too difficult to understand in order to get. That is not actually too hard because you know. Classically, what would you do? Classically, what would you Tasha's velocity in phase direction? Be like horseshoe, right? You just add them together, right? So I just be like, oh, okay. I think I just said so. I just be like, that's not how I normally talk. It makes sense. You do it like this.
Well, yeah, that's how.
Right? So you can work that out in more detail with the reference frames if you like. It'll work out the same way. But you should have plus signs at the top and the bottom.
You should definitely.
Okay. Then let's work this out together. I should refer those to fractions. This is 2/5 C on the top. 1 plus 1/5 times 1 plus C don't cancel. 1/5 times 1/5 is 1/25. So you get 2/5 C over 26 over 25. Which gives you 2/5 times 25 over 26. Cross cancel and you get 5 over 13 C.
I was supposed to cross multiply.
For Tasha's velocity in phase reference. Now you're in phase reference frame basically. Okay? And since you're in phase reference frame, you know it takes 2 seconds in your reference frame. And all you have to do, and you know that Tasha's waiting 2 seconds in her reference frame. So now all you need to do is a time dilation on 2 seconds. Okay? But it has to be a time dilation on Tasha's speed in phase reference frame. Otherwise, you're finding you in the wrong reference frame. So you'll need to find gamma for this one. It's a little bit messier. 5 squared is 25. 13 squared is 169. Actually, you should not. You should. If you know your triangle, you should know how this comes out. 169 minus 25 is 44. 44. Haha. So you might go to 13 over 12.
I know.
And so then the results you get is the time in constant reference frame is gamma 13 over 12 times the time in phase reference frame, which is 2.
I think I've ever.
Which gives you 13 over 6. Hang on, that's the total time after counting 2 seconds, right? In phase reference frame, it's 2 seconds. In her reference frame, Tasha takes 13 over 6 seconds, so the actual difference between them is 13 over 6 minus 2,
Shouldn't
which is
it
1
be?
second.
Never mind.
Both of those work. Like I said, the second one is fewer tracks in it. There's still a lot of room for error, and like I said, if I can figure out that you were doing about the right thing, I try to give you the relevant partial credit, but only if I can figure it out. Okay, like I said, a little harder for level 2. Non-positive function. And so, number 5 is the speed of Tasha's ninja star in phase ninja star and Tasha's reference frame. Not that it matters, by the way, right? This is a perfectly symmetrical situation, so the speeds won't change. For this one, you have to do it with 2 velocity transformations. There's no way to do it with a single one. You must do it with 2 velocity transformations. Now, if you did this one earlier for number 4, you already have one of them. You have Tasha's speed in phase reference frame. Or, if you prefer, phase speed in Tasha's reference frame is 5 over 13C. Okay? Knowing that, to find the stars, and then the star speed, whatever, in Faith's reference frame is 0.7C? Is that right? Yeah. 0.7? Yep. Yes? Okay. Okay. So, therefore, you just need to do, 513. 513 is okay. If you had it done this way for number 4, you would have to calculate this for this one. There's a few different ways you could do it that are all equivalent. You could have put both the first reference frame first and then switched to Tasha's, and that would be fine too. But it always takes 2, no matter what. And then you say, okay, good. Well, phase speed in Tasha's reference frame is negative, right? So I know the star speed in phase reference frame. I want to know the Tasha's reference frame. So Tasha's speed in phase reference frame.
Wait, 1/2, 4, what?
Positive then, right? Gosh, could be that way. It fits on the left, right? The star, phase throws it this way, so it's got a positive speed. So to do that transformation, this is your use of X, this is your V. So we get 7/10C minus 5/13C over 1 minus 7/10C times 5/13C over C squared. Cancel. On the top, do you really have to do this? Yes. It's not so bad. So to do this one, you do 13 times 7, which is 91, minus 50 over 130, right? And then on the bottom, we have 1 minus, some of this is cross cancel.
Something between B minus and
so you get 7 over 26 on the bottom. And so that gives you 91 minus 50 is 41 over 130. And on the bottom, 26 over 26, so 19 over 26. And then you get, so you got 41 over 130 minus 26 over 19. I believe there's something, yes, this is divisible by 13. That's 10 and that's 2. Oh, divisible by 26, I guess. There we go. And 41 and 19, do they work? They do, don't they? Yeah? Wait, that's not right.
What?
Do they not?
No.
Okay. 19 times 3. Yes, that was off by. That was off. Thank you. By that. They don't. Okay, good. So we have this, right? So this gives you 41 over what's 5 times 19?
42 and 18 would work. 41 and 19 doesn't.
Yeah.
I think he was a little confused.
Is it right?
Yeah.
That's fine.
Almost 19 is a factor.
Keep it well organized.
And
But
41
different
would be a
numbers, yeah.
Okay. Again, if I could see what you were doing, in particular, if I could see that you were doing 2 velocity transformations, that was worth some partial credit. If you got one of them right, then that was worth more. Right? If you got one right against the other one, then that was worth more. But again, I had to be able to see what you were doing. Okay, finally, the sheet and the stick. A few people got confused about how the sheet was drawn. I don't see it. To me, it's pretty clear how it's drawn. But the stick is moving like this. The sheet is on top of it, right, with a hole in it.
Sheet's moving like this.
Yes, and the sheet goes down over the stick.
The stick is
right?
going like this.
Yes. Okay. I think that's how it's drawn. I don't think there's any way to there's any reasonable way to interpret how it's drawn. But some people were talking about the sheet like it was going this way. Okay. And like I don't know, it's not drawn that way. It would be drawn differently if it were like that. And you could always clarify things like that with me. But anyway, so here's the reason you should make sense of this, right? Is that the stick going by its length contracted, so it's much shorter. Therefore, it's like this. It's smaller than the hole, so I pull the hole straight down, and I should be able, if I'm fast enough, I can go right over the stick because the stick is shorter than the sheet. The problem is, in the stick's reference frame, the stick is now the proper, 4 meters? And what's the hole look like? The hole's really small. So the stick's reference frame, now it's the hole that's moving, right? The stick stays stationary, the hole's moving. There, the hole looks hopelessly small. It cannot possibly work its way around the stick. And so in the Earth's reference frame, it looks like no problem. In the stick's reference frame, it looks like big problem. And the solution is the same as
the cookie cutter,
right? In fact, if you just imagine it as a cookie cutter, that hole, basically that hole, the hole drops down like this in the Earth's reference frame. Therefore, in the stick's reference frame, the two do not drop at the same time. Instead, one part drops first, and then the other part follows after, causing this kind of weird twisting thing that we saw with cookie cutter, right? It kind of twists like this, slides around the stick, and, it comes down to a twisted angle, slides over the stick, and then keeps going. Right? That's because the failure is simultaneity. I did my best to give partial credit on the two based on your explanation. But if it wasn't super clear, you didn't get the whole thing.
Basically, all I have to say is
but you should recognize it is basically the same as the cookie cutter problem.
I feel like that if you had switched this problem with the cookie cutter problem, like had this in the worksheet and the cookie cutter problem here, I would have gotten it wrong. I don't know why, but
okay.
Well, that's that.
I have nothing to say to that except that it would be much less exciting if I brought in sheets of paper with holes cut. So
You were sick that one day.
Did I actually miss that?
Yeah.
I missed cookies.
There are no more questions on
We didn't
the
eat
list.
cookies, did we? Did we eat cookies?
We ate edible ellipsoids.
Are you kidding?
We had to test the experiment.
You guys are fucking with me. No,
No, we didn't. We did eat cookies.
They were good.
No.
I was gonna grab you one thing, but that's not.
Dude, it was the best thing ever because what happened is that he told us the answer, and then the cookies he gave us were length contracted. They were like,
Not like contracted, they were
with
extended.
an oblong.
yeah, it was so.
That's so upsetting. No, you guys have got to be making that.
I didn't ask him.
I
We didn't actually make cookies, he brought them in.
I know, but I don't
Wait, he
believe
didn't
you.
make them?
Oh my goodness. Did we actually have cookies the day I was sick?
Wow, did we really?
Yeah. Oh my god.
Ethan, I'm sorry.
Okay, and then one more
let's
thing I
make
wanted to
another
ask
batch.
you
What's the
about number 3 on my test.
Yeah, no. For people who did a velocity transformation but did it wrong, that was this.
See, but I had everything right up until here where I went to cross multiply it twice.
Why do you cross multiply?
See, if I'd cross multiplied down there, I'd have been fine, and then if I just multiplied up there, I'd been fine, but I went to cross multiply and I cross multiplied again.
I'll think about it.
Okay.
I got almost the same. I got the same answer you would have gotten. I did not cross multiply it all.
Okay. All right.
It's just so bad for you. It's like so.
I didn't grab your computer. That's how I was allergic.
It's okay.
Please tell me it's
He's
easier.
nice. It's like you probably
Easier, please.
I don't believe it.
That is not what most people say. But it is
What do most people say?
It is not. It is different. It is not about. You don't have to worry about the signs of things so much. Those minus signs are not going to
I just don't want
be a problem.
That's the entire thing of this class.
And those problems go away. It's not primarily about the minus signs. And that's,
All about reference frames.
The entire freaking class.
We are now going to tackle the problem of light.
No!
Yeah!
Problem. That's not the whole unit, by the way. We're going to start by the problem of light.
Wait,
Here's something. This light. Wait, this is the Earth.
This is my favorite thing in all of physics.
What happens to the Earth when the light strikes it? The Earth gets warm. If the Earth gets warm when the light strikes it, that means that light must carry or have energy. Good.
We proved this.
We did. We're going over it.
Very clearly empirically true. If the only thing the sun sends to us is light, which appears to be true in every radiation sector, then that means light must carry energy. All right. We have actually other lab measurements that show the same. It's quite clear, because light warms you up, therefore it has energy. Okay. What happens when the light actually strikes the Earth? You zoom in a lot, and these are individual air molecules. Okay. What happens when the light strikes one of the air molecules?
It moves faster.
It makes it
Faster.
Yeah, it makes it move, right? It makes it move and it changes its direction. If it makes it move, that means if it collides and makes something else move, that means that light must carry.
Yes.
No.
Wait, what? Excuse me?
Yeah. Although that means that.
Because that's, you can't say, the other things aren't things you carry. Well, momentum is a conserved quantity, right? So we know therefore that light has momentum.
Okay.
Okay, that's a conserved quantity.
I
Therefore,
saw it
if
in
they
it.
start moving when the light hits it, the light must carry momentum. Again, lab experiments have confirmed this. Light carries momentum. That means that when you tailgate someone with your high beams on, you actually are helping them move faster. You're slowing yourself down.
Which is more no.
So, you're shooting out all that light.
Not
Yeah, you're right.
any reasonable, noticeable amount,
Is
but
it any
Anyone
measurable
searchlights on the back. The amount of momentum light carries for the record is not very much. All right. It is not actually a good idea to tailgate people with your high beams on to make them go faster. All right.
They might go faster for a different reason.
You must carry momentum. That's just empirically true. Okay. I'm going to have to tell you one thing that I will prove later, but right now we'll just have to accept it. Unit-wise, what's the unit of momentum?
7. Oh my God, he's going to talk about
is he gonna talk about wave particle duality?
Joules, what's joules? Let's take 1/2 mv squared, so kilograms times.
5 right now.
Oh, I think we are.
All right, what's the difference between their units? A factor of what? Units per second. That's a factor of velocity, right? So, what would be a really convenient velocity to use to go between the momentum and energy of light? C. Right? Why not? So, this actually turns out to be true, even though that was a bogus argument I just gave you. We'll do it right later. Okay, but for the moment, this actually was known based on Maxwell's equations. You can derive this from Maxwell's equations. So this was known in 1900. For light, the correspondence is that E equals P times C. Okay, Maxwell showed this from his equations. We'll show it in a much nicer way later. But for now, you have to accept that. All right,
So it's the energy equals the momentum
this
times
is
the speed of light?
Oh wait.
Here we go. Imagine a train car that is not moving relative to the earth. It's just sitting there.
Whoa.
Okay? According to Newton's first law, if this train car is just sitting there, then it will be, no momentum in there, and it will, over time,
Stay there.
stay there, right? Do you agree? Now, what does it mean for the car to stay there? Because the car is an extended object. Really what we say is the center of mass stays there. You can shift things around inside the car, right? But like the total amount of mass to say that the whole car cannot just go off to Tennessee, right? Because that would violate Newton's first law. Okay, good. So, let's say you're over here, and let's say I have a flashlight. And I shoot the flashlight. Perfect. And I shoot the flashlight. Now that flashlight shoots a beam of light that has a certain energy. Okay, good. If the light has energy, it also has momentum. Good. The momentum just from this is going to be equal to E over C. Agree? Good. If the light just was generated by the flashlight. Yeah,
The E or the is momentum.
E is momentum.
But momentum is energy.
There's a sign on it. So if you like E equals plus or minus B over C. Right. There's a sign. We're only doing one dimension, so it's really on magnitude. Okay. But we're only going to do one dimension. Okay, good. So if the light didn't exist before, it's generated by the flashlight, right? So when you shoot it off with this momentum, what else has to happen? There has to be a recoil, right? There's momentum, right? Conservation of momentum. So what's going to move? The train, right? I'm saying the train, it'll track the train. The train's on wheels, real new wheels apparently. So the train will go backwards with the momentum of what? Negative E over C. Well, yeah, I can ignore that. It's going the opposite way, E over C. Agreed? So the train starts moving. That's no big deal. That'll happen with anything. You take a rock and throw it to the other side, the train will move. Probably a very small bit. If there's no friction at all. Okay. Okay?
Other than a friction,
That's just
friction is not
existing.
About when the light hits the other side.
Good point. What will happen when the light hits the other side? Its momentum will be transferred back into the train, and the train will stop. Quite right. Same as with the rocket, by the way, right? It'll move it, but then it hits the other side, and it'll stop.
So it moves while
Okay, so here we go, and it stops. Good. Now, how long does that trip take?
very little time.
L. Okay, good. So how long does that trip take?
L over C.
Good. All right. Now, in the meantime, what is the velocity of the train? Let's say the train is mass m. E over mc. You remember what momentum is?
No.
Momentum is mass times velocity. Remember that? Okay, good. So this is going to be E over mc, right? Momentum divided by mass. So E over mc.
The time is the length
The velocity of the train, right? So in the time that the light is traveling across, we don't have to worry about funny relativistic effects. Okay, we're all on reference frame. So in the time that light is traveling across, the train will move, right? How far will it move? It will move some amount I'll call delta x. And delta x we can get easily enough. How would we find it?
Greater than mass times c.
It'd be what? It'd be, to find the distance it moves, you should take the velocity times the time, right? So velocity, E over mc times the time, L over c. You do E L over mc squared. So that's how far the train moves when you fire the light. Okay, there is a problem with this. A big problem with this. Can you see what it is? What if I take the light bulb and I shoot that light beam, the train moves that amount, right?
Mm-hmm.
Now I do it again. Now I do it again. Now I do it again. What's going on?
You'll move
The train moves. Could I keep doing this? Yeah, I can keep on doing this. And what happens to the train? It moves without an external force acting on it. It's a tendency. Right?
Eventually.
Because this is an internal force. It's completely self-contained within the train. Right? It's an internal force. The external forces are not allowed to
excluding friction.
What? They're excluding friction.
Huh?
This would be a station.
Stand for mass. What does M stand for? M stands for mass.
Right? So that would allow
Do you
to
realize
move-
that we're deriving
to move
E equals MC
without,
squared? I realize
with an internal force, which is not possible from Newton's laws.
Yep.
I have a problem with velocity equals energy over mass times c.
Why?
What is the mass?
No.
What mass are we measuring?
There's the train.
Mass of the
This makes the
train.
train move.
Oh, okay.
Not the mass of light. No, stop. Stop.
Undefined.
Stop.
And that's really actually one
It's here.
photon.
No.
No.
Oh, I wait until
Why?
it stops. And then I
What
do
is
that
it then?
one. But each one actually was one.
That's a good
How much does a photon weigh?
Yeah.
What is the mass of the photon?
Okay. So this is the problem. You see why it's a problem? Yeah. Wow. Okay. Einstein comes up with an interesting proposal. So here's the proposal. What if?
See,
So here's the thing. This is different
energy
from
is
throwing
equivalent
rocks.
to mass.
Throwing rocks is no
Energy is
problem because
equivalent to
why? What's going
mass.
happen
So if a
is not
photon has
gonna
energy, then it has mass.
Well, yes,
It's a-
but it's
shifts
mass
for a
accelerated to the
velocity,
speed of
eventually
light
what's going to happen? I'm
squared.
going
Uh-huh.
to, well, maybe, or
So
run out
it
of
gets
rocks.
really, yeah.
Because I only have so many rocks to throw, right? And so eventually we'll run out of them. I will not be able to move all the way to Tennessee.
I feel like there's some
But in
sort
the case of light,
they shouldn't have mass.
that's not happening, right? So what happens when I throw a rock,
I
it
said
shifts the
accelerate
mass.
the speed
All
of light
there's no
squared.
actual
Does that
change,
mean
just
shifting
shifting
the
mass
light?
from one part to another. Well, with the light, it appears like I'm something moving out of nowhere. I'm getting momentum out of nothing, right? So he says, well, what if light has mass? What if? Well, we can calculate how much mass it should have. Okay? Because let's assume that it's an even mass distribution for the train. Okay? Let's say it's got an even distribution of mass throughout. That's to say that the density is always the same. So density is mass over length. That this is the same ratio no matter how much length, right? Well, how much mass would the light have to have? It would have to have enough to offset this much mass of the train, right? Because that's the amount you want to shift to the other side. See, if light had mass, then you would just be shifting mass. from one side to the other, it'd be fine. You wouldn't be able to go to Tennessee because you'd run out of mass. So you shift it from one side to the other like that. Okay? So how much do you have to have? Well, you have to have a little m, small m, mass of light, and delta x amount of length, right? And we're saying it's evenly distributed, these should be the same proportion. Okay, let's just take this and solve for little m. N equals big L over L and delta x. Substituting in for delta x, we have big L over M over little big L, E L over MC squared. L's cancel, M's cancel. And this is how much mass the light would have to have for this to work. Okay, there's a problem though. What's the problem with this proposal?
It's just light has mass.
Yeah, what's the problem with that? Light. Yeah, well, why is that a problem? Think about that equals ma. Light has mass, that would allow it to do what?
Go faster.
Accelerate. Can light accelerate? No. In every reference frame, light has to go C, right? So it cannot accelerate. So light cannot have mass. We have plenty of other experiments, by the way, we've actually measured just to make sure, and light does not have mass. But also it couldn't, it would mess up everything, right? And we measured it, it doesn't. Light has no mass. So this is wrong, but it would fix the problem, you have to admit. So Einstein says, okay, that won't fix the problem, but it comes close, right? So let's try another one. This is the actual right answer, which is.
Should I cross out all this word though?
Not the whole word, no, just that one line. Light is not a mass, but what if light is particle? What if mass is, look at what's in this equation. Mass and energy. What if mass is a form of energy?
See, yeah.
Because that would work too. Because then what happens is something gets converted, some energy over here, some mass over here gets converted into light. The light comes over here, and where does that energy go? It gets converted back to mass. And now you're still distributing the mass. Right? So Einstein makes a proposal that mass is a form of energy. That mass is, what do we know about energy? What can you do with energy? Convert it into different forms. So you have light energy, you have sound energy, you have kinetic energy, you have gravitational energy, now you have mass energy. That's another possible form that you can convert between. And we've already figured out how that conversion works because we've calculated what the mass has to be, we just spin it, and rather than looking at the mass, we look at what the energy has to be. And what does the energy have to be?
Mass times the speed of light squared.
There we go. Woohoo! And thus, Einstein's most famous equation, this in probably its simplest derivation.
Okay. I'm like, that's not the full equation, though.
This is just a ratio of densities. J-House basically does a lot. But saying, I said it's a uniform density, like the mass is equally distributed. So that means the ratio of mass over length for any amount of the train should be the same. So the whole mass over the whole length equals a little bit of mass over this little bit of length. And so it's proportional. Yeah. Okay, you do not need to worry so much about the derivation. You should worry about this. Because it tells you that mass is a form of energy. And not just a little bit of energy. Let's think about this in SI units. If you have 1 kilogram of mass, how much energy is that in joules? 3 times 10, 9 times 10 to the 16th joules. Do you know how much 9 times 10 to the 16th joules is?
A lot.
Why, that would be enough to blow up a city. On a bad day.
Oh my word.
Do you get where I'm going with this? Right? If you could liberate mass energy all at once, it would be incredibly destructive. You could take out a whole city with one bomb.
Who knows? You could end war.
Mass energy conversion. Energy converts between different forms, but not like by willpower. You know, not like because it wants to. You actually need a mechanism to convert things from one form to another. Mass mass energy conversion is a very, very difficult mechanism to do. There are very few forces that allow you to do that. And as such, we cannot just do it by snapping our fingers. But there are a few things that do. Yes, Mike?
So, we have proven by testing the various other devices that we can convert mass to energy, but how about going backwards?
You can. We have not done it at any large scales.
Because the amount of energy would be
We have a lot of mass, and we have an energy crisis. But if we have a mass crisis, we'll go into that, right? But Americans do not have a mass crisis.
We do have a mass crisis.
Yeah, it is possible to be done at very small scales. In fact, we'll talk about exactly that in part of
In class, yeah.
Class is over. I'll have something to listen. There's some homework that is about light. Okay? All you need is this equation.